15.2 ArrayList methods. Okay, so there are many more methods than this in the API, but these are the ones I'm going to focus on because these are the ones that are frequently used. I'm going to walk through each one and then show an example. I'm only going to work with list 3, an ArrayList of strings, just so you could see how all this stuff works. First, since we're only working with strings, I want to make something clear here. Whatever I'm doing here with the strings work for all of the types. Okay, so if I were working with doubles, it would be the same thing. Okay, the first thing I want to check out here though is all the methods that we have. How do you put things in the list? You add them. There are two ways to add. You can simply add an object, any object that of the specific type, or you can add the object at a specific index. Now this gets a little tricky because the index has to be in bounds. You don't want to add it to an index that's out of bounds. So let me tell you, 0 all the way up to size are all valid. No negatives and nothing bigger than size. So if you have 10 things in a list, you can add in our position 0 to 10. I know 10 sounds like it's out of bounds because it should go to 0 to 9. But you got to remember, because we are adding to the list, it gives you the ability to add one extra one on. So because there are 9 things in a list of 10, true, it could add at position 10 still because it add an extra one. Set, same idea here. The set needs to set at a specific index that exists. Okay. Get, same idea with the index, and remove, same idea with the index. Remove have two ways to remove. We can remove at a specific index. We can remove a specific object. Okay. Size, we saw this one before. That tells me how many are in there. Is empty. Nice method here that says, well, is this list empty or not? To array. That turns the list into an array. Told you they were very similar. Now, here's the deal. I am going to check these things out. I'll start off first with is empty. So I'm going to say system .print and I'm only going to work with list 3. So list 3 dot is empty. Now I like the code completion. You can see when it comes up. And this is the first time I'm going to run this just to see it says true. Alright, it says true because the list was created but nothing was added to it. So it's empty. Now, how do I add to it? Simply call add. List3.add. Since it's names, I'm going to add in here. I'm going to add cake. Okay. So just now I added the word cake to the list. I used that add. Okay. So I'm going to go ahead now and print the list. Another good thing about lists is that once you print the list, you could print the name of the list and it would print it nicely. It's not like an array. An array, you have to write a loop to print it. But with this, look at this. Look at how nice this is. Bam. See the list? It has cake at position 0. If I wanted to add some more, which I'm going to do. So I'm going to copy this and just add a couple more. Actually, you know what? Let me add them right in here so you could see. I'm going to change the names, of course. I'm not going to say cake. Let's say bake. And let's say make. And let's go with take. Okay. So let's see now. The list is empty up here. But once I added these, it's not empty anymore. Look at that. See how nice this is? Because it shows where the stuff is added. So we have the cake at position 0, then the bake at position 1, and then the make at position 2, and so on. The next thing I want to do is I'm going to go through all these methods here because you can see how nicely that I could add a specific index. So let's say I wanted to say list. Let me do them all here. So I'll just print it once. List 3. I wanted to add at position 0 the word Ben. Okay, let me do uppercase. So because cake was once at 0 and I'm put Ben at 0, you know what's going to happen to everybody? They're going to get pushed to the right one. So cake is going to go to 1. He's going to go to 2. Let me run it so you can see. See, remember, cake used to be at position 0, but when Ben came in, he doesn't erase cake, he pushes everybody over 1. That's the add at a specific index. Let me show you what I mean by adding out of bounds. What about if I want to add at position 10 the word can? See, this is not good because position 10 doesn't exist. There's no way I could add to position 10, so it's going to go out of bounds. See? It tells you the size as well. Say, hey, only 5 things. You can't add at position 10. Okay, so we got to be careful when we're adding with these indices here. That's the add. Set. Set is a different type of add. Set overwrites what's there. So if I say list 3 set at position 0, if I say set at position 0, I'm going to put the van. Now if I do that, you can remember Ben used to be at 0, but when I do set at 0, I will now get rid of Ben. He will not be in the list at all, because what set does, it puts the van in, but it erases the Ben. Now another sweet part about this, since it's a list of string, I can hold only set here now. Don't get crazy, not all of them have this ability. The set returns what was there before. So I'm going to go ahead and now print not the list, but I'm going to print Ben. So you could see that Ben, when you set van where Ben used to be, the set returns what was there before. So you're going to see the list and you're going to see Ben. See, Ben was once here, but van took his place. But now I have it. Why do that? Well, data structures, when you have a data structure, if you're going to make a change, like erase something, you want to make sure you have a copy of what was there before in case you want to save it for some reason. Okay, so that's add and that's set. Get. You can see these setters and getters, I tell you. They're all over the API. So you could see a get. Now get actually says get me the guy at a specific spot. So they're all strings. So I'm going to say, let me call this take. I'm going to say list 3 dot get me the guy at position. Now I want to figure out what position take is in. So van is at 0, okay, and you're at 1, you're at 2, you're at 3, and take should be at 4. Let's try that. Let's see if take is at 4. Let's print take. Let's see if that works. Yay, found it. 0, 1, 2, 3, 4. Obviously, if I do get and the position doesn't exist, we're going to have a problem, right? Like if I say get me the guy at 5, well, we got an issue, okay? So there's a little tricky thing here about these indices. The tricky part is when you're doing a add, it allows you 1 extra, okay? But when you're doing a get, there's no allowance for that. You have to be exactly one of the indices that exists. Remove. Well, obviously, if you can add, you can remove. 2 ways to remove, by the way. I could move the guy at position 2. Okay, once I do, I don't want to do add, I want to do remove. I could move the guy at position 2. So let's run that and see what happened. Okay, so it's van, cake, make, and take. So let's go ahead and print these two so we could see the actual remove in action. Okay, so I'm going to put the print here. So look what happens here. Now, the first time we had the list, it looked like that. We override the ban here. Now, what happens here is that the position 2 that we removed, it was 0, 1, 2. Bake is gone. So what happens to make and take? They don't stay where they were. They slide to the left one. Okay? Slide to the left one. So we got to make sure we get something clear here. And add would add 1 on the end. And add at a specific position would put the stuff in that position, but move everybody over to the right. A remove would shift everything to the right, 1 back to the left. Obviously, if you remove the guy at the very last spot, nothing shifts. The thing just comes here, and we're good. But once we're moving any other position, everything to the right of it shifts over 1 spot to the left. Be careful with that one. No, that's one way to remove. We could also remove an actual, let me just undo that. We could remove an actual value here. So we could remove the make. Okay. So when I run this, we can see the list now. See, make's gone. I didn't just remove the guy at position 2. I also removed this specific word make. What would happen though if we had more than one make in the list, right? So let's go ahead and add like a couple of makes. So when we run this, what would happen? You thought it would remove all. No, it doesn't. It removes the very first make, not all of them. Okay, so this had a bunch of makes, but when I remove make, it takes this one out. Then everybody gets shifted over one. Okay. All right, we're almost there with a couple of these methods. So we did the remove, and now we're gonna check out the size. I'm just gonna print it. So system.out.print ln list3.size. I'm going to put it a couple of places so we could see how the size works here. And this is the concept of growing and shrinking. You see how things are moving to the left and to the right? That's the grow and the shrink right there for you. Once you're calling add and once you're calling remove, things are going to be moving. So this is a very dynamic list. You see, it was 8. Now it's 6. So obviously not like an array where things are kind of fixed, right? We don't remove things, but in this structure here we remove. And finally, let's go to array. Speaking of arrays, yeah, I'm gonna say here string, and it's an array. Don't forget how to make one. And I could say list3.toArray. Now you'll find that you get an error here. The reason why we get an error here is because the array that we are getting back, because they don't know for sure what's in the list, the API turns them all into objects. So what we got to do here is cast. Now this is a little tricky, only because you have to make sure you know what type is in there. So you got to be very careful as to know what type is in there. Now, see, I turned this into an array so that I can see what's in position 1, let's say, or something like that. So let's go ahead and do that. We're going to print array at position 1. So if I run this, let's see if it works out with what we're thinking. Oh, it says the object cannot be cast to a string from an object, from object. So they want us to not cast this to a string. They want us to cast it to an object. Now realize it's uppercase O for object. Now let's go and see if we could print this. So you see it prints cake. Is that in position 1? Yes, it is, 0, 1. Now, that's the only little dangerous piece here. This is not something that we're going to use a lot. We're going to basically use the other one. That's why it's last on the list. It's just to show that the array list is so close to an array that the API presents a way to turn the list back into an array. All right, this is 15.2 ArrayList methods, where we're adding, we're setting, we're getting, we're removing, we're checking the size. We're also finding out if it's empty or not, and we're converting it back to an array. Like I said, this method is not going to be one that's used quite often, but the other ones are. Okay. 15.2. That brings us to the end of 15.2.